looked at these, remember we remember what our cosine graph looks like? Yes? We know it like the back of our hands now. It's almost as happy as our sine graph. So we know that it starts, just drawing it over here, I'm not doing it underneath, but it starts up, it comes down, and then it goes up again. It takes how long to complete one wavelength? 2 pi, that's fantastic, right? And then we've got pi in the middle, and so we know it cuts here at pi on 2, we know it cuts here at 3 pi on 2. That is linked, really closely linked with, oh, that's a good circle, with our unit circle, okay? Because here, that's 1, that's where your cosine starts off at 1. As it goes around the circle, right, it's going around the circle, your cosine is now 0, that's where it's at pi on 2. So it's not like something different, it's all linked. All right. When it asks you for question 4 to state the max or the min, those of you who have done it, what are you looking at? What do they mean, the max or the min? Yes, it's the height. And so what part of this function is telling me about the height? Excellent, the A, the amplitude, because what that's doing is it's stretching the graph. So if we had our usual little, I'm going to draw it little, and you could use your calculators to do this. It goes between 1 and -1, obviously didn't leave enough room. What the 4 is going to do is it's going to just stretch it like so, just pulls it. So that's why we know we're going to now have a max of 4 and a minimum of -4. What does the 2 do? What does that 2 do to the x? Yes, you're doing actions. It stretches it or compresses it. And in this case, is it going to stretch or compress? No, this one's going to compress, right? What that is saying is you are going to now have 2 of these cosine graphs within the same period of its normal one, so 2 pi. So therefore, I can tell you straight away, I know the question's not asking for it, but I can say straight away, I know this period is going to be the period. The B value is 2, but what's the period, aka the wavelength? How long does it take to complete one cycle? Pi. And we get that because we know our formula is 2 pi over B, and our B is 2, and that's why we get our pi. So it didn't ask you for that, but we should be realizing what the graph looks like. We happy? Okay, we go onward. People are writing, so I think I have to pause. Is that correct? B, same deal. We're looking at the 3, and we are straight away in our mind going, it is now stretching it from 3 to -3. Period is not affected because we've got the 1 in front of here, but, oh dear, what does this 5 do? It lifts you up. That's right. Right? So you can walk on, I don't know, my wings? I don't know the words of the song. But it lifts you up, lifts the whole graph up, keeps the shape, lifts it up. So now, when we had here, we had a maximum of 3 and -3. Obviously, each one of those has lifted up. So therefore, my maximum, instead of being 3, my maximum is now 8. And my minimum, right, -3 plus 5, a 2. Pretty nice? Okay with this? And if we go back, if that was sine instead of cosine, exactly the same situation. Yeah? They're really testing us now with part C. Is this -3 here, is that going to have any effect on my maximum or my minimum? Niet. What does the -3 do? That is your horizontal translation, and so it shifts the graph. Which way? That's right. When it's -3, it shifts the graph to the right. Again, works the same way for sine. So we did that last time. All right, so all we're having to look at now is our -2 and the -4. The -2, again, stretches the graph. Yeah? Stretches to between 2 and -2 still. What does the minus do? It flips it, but it's still got to have a max of 2 and -2. It's just upside down. And then the take for, so again, we can say here we're going between 2 and -2, but then we're taking away 4 this time. Geez, aren't they clever? So my maximum will be 2 take 4, which will now be -2. I feel odd writing my maximum as a negative, but anyway. And my minimum will be -4 take 2, which is -6. From last lesson, right, with the sine function, we were able to work out our amplitude. If you couldn't just see it, we knew that we would take the max from the min, divide by 2. It gives us our amplitude. Our principal axis, that's our D value. That was the average of your max and min. We know this now. The formula for period is 2 pi on B, and we also had to look out for C, which has our horizontal translation. So we come to 5A, and we look. We go, okay, pretty simple, I think, that we can see what our A value is. Do we agree? It's going up to 2, down to -2, so everybody happy that our A would be 2. Sorry, Heather. Right, the other thing, what do we look at with what's our B? The period. So pretty easy to see how many cosine graphs can we see within the space of 2 pi. Oh, that's massive. I can see, oh no, I wanted my highlighter. Yep, we can, come on highlighter. It's a white highlighter. Right, we can see 1, and then we can see 2. And I know you could see it, but I just wanted to use my highlighter. So we've got B, is 2. Okay, has the graph shifted left or right? Niet. So our C is 0. And what does the D do again? That's your principal axis, that right lifts it up, lifts it down. And so we can see right through here that our principal axis is in fact 0. Okay, so therefore pretty straightforward. We will have 2 cos 2x. Happy days? If I was writing a test, I've said this before, it won't be just write the equation, explain why, or justify your answer. Okay, so it's not just typing things randomly into your calculator and doing your guessing. All right, so C was the one that posed a couple of questions from people. So give you a moment to have a look. What can you get down? So on your page, write down what you can say. I don't know what I'm talking about. We've got volunteers from the class. We can see here that we've got an amplitude of 5. And notice I've left a gap. So don't write it right next to your equal sign. You know what's coming. All right. What about our period? This is the bit that got people a bit stuck. So remember, we know our period is 2 pi over B. So that's saying how long does it take to complete one wavelength? So how long? It takes 6, that's right. So I just want to use my highlighter again, right? We are taking 1, and then that stops because now this next one, it's repeating. So it takes 6 units, radians, whatever, to complete one cycle. So we've got 6 equals 2 pi over B. Can you be careful with your 6s and your Bs? My year 10s yesterday, they were mixing up their A's and 9s. Their own writing. They were writing A, and then the very next line they wrote 9. So do be careful. And we know now when we've got the unknown downstairs, what do? Switch. We do the switcheroo. So we've got 2 pi over 6. And therefore B is pi on 3. So that little formula, period is 2 pi on B, it's really handy. If you've forgotten about what period is, write yourself a little note, how long it takes to complete one lap, one cycle, right? You've got to remember that. All right. Now C. Sí, señor. What can we do for C? Has it moved left or right? Well, technically, I would say yes, it has, because your cosine graph always starts up the top. But we can do a couple of things. What makes the graph go downstairs? Negative. So I can come back here and I can write that as negative. So we've therefore got y equals minus 5 cos, what did we say? Pi on 3. Pi on 3x. But it would ask you now, I'll pause, and then I'm asking you to get your calculators out, please. Challenge is what happens if I said, nope, I want my A to be positive. So it has to be 5 cos pi on 3x, and then you have to come up with what's your C value, because you can see here, oh, don't tell everybody, right? They're just calling it out. You're moving it this way to the right and just have a look, yeah. Just shifted. Oh, look, okay. I wanted people to discover it, but they're going, yes, it's halfway. So it's a shift of 3 units. God, they just ruin it. That's all right.
I don't think
that's Addie. That's Addie. And Piper. Out of your A, B, C, and D, which do not change your x-intercepts? Does not affect your x-intercepts. I've heard from the crowd A and C. Do we agree on that?
No,
just A, that's right. Why doesn't, why do we rule out C?
Because it shifts.
It shifts it left or right, so that's definitely going to change your x-intercepts. These are just past questions that I've put when I've written tests and explain why. So I just chuck them in. Okay, do you need a moment? So, last function that we're looking at. Now this is stuff that you already know. We already know that tan is equal to sine over cosine. Do we agree? I have cut and pasted this from our OneNote when I put the bookmark there. This is your cosine graph up here. We know that already. But here's your tan graph. It's got an interesting shape, so it's different to the sine and the cosine graph. It's not a translation. And it's got these dotted lines here. Does anyone know what they are called? These dotted lines that go, this thing here. Do you know what that's called? Oh, I like saying vertical. Very good. So this thing here, these are called vertical and you don't need to write anything at the moment because in a tick I'm going to ask you to actually sketch your tan function. So notice, why have I included the cosine graph here? Can you see they line up? I did that deliberately, took me a while. And that is because you cannot divide anything by 0, right? So when cosine equals 0, we get an error. It is undefined. And that's why we have this thing called a vertical asymptote. Does that make sense? Also, think about, I should put my sine graph in here now as well. Let's go sine graph. So if you think, let's go, I don't know, when you're getting closer, say, to pi on 2, what's your sine value? Quite large? Like nearly 1? But what's your cosine value? Very small. So what's happening when you're dividing a large number by a small number? You get a big number. That's why this goes up and up. And this just keeps on going and going and going and going. Right? So if you have a look at your textbook, your tangent function, It's a better sort of, it just keeps going all the way up. So this will just keep going and going up, up, up. It will not cut. It will not cut that asymptote. All right. So what are we going to do? We are now going to try and sketch our tan graph really nicely. So this is what you're going to do. Get your ruler, and the same way that we did the sine and cosine, you're going to split it up into 4 sections. You've got your 2 pi, you've got your pi, you've got your pi on 2, and you've got your 3 pi on 2. Obviously you're using a ruler, and you're going to go like make this y-axis a little bit larger than you would have your sine and your cosine. And I'll wait. Sorry, Lil wasn't recording, but we just had practice drawing in our curves. Right, you have to put your dotted lines in first, right? Draw them in first. And then try and do your curves, and do not, I repeat, do not touch the asymptotes. You can't just go, oh, oops. Do not touch. And I've seen ones that go like this. They've come in from the side and then they curve back out again. Don't do that. You can't curve. Go on. The things that I want you to note in your book. First up, oh, come on, I went red.
Perfect, but not.
Perfect, but not. First up, the amplitude of tan. It is undefined. Why? Yeah, just basically because of that definition, undefined. We cannot define it. We can't give it an amplitude because it just keeps going and going and going forever. Okay? There have been test questions in the past, and you will see them in the practice tests, where it says, what is the amplitude of tan? And students will say 4, 3. So if I have an equation and I go y, oh, red comes out quite nice on it. I didn't realize. So y equals 5 tan 2 x, and they go, what's the amplitude? Guess what students will tell me? 5. You go, no, it's not 5. Yes, that just makes it does make it stretchier, but it just keeps on going and going. So the 5, it would probably be a little bit like that. Just like pulls it. Okay? But it's the amplitude is still going to be undefined. What do you think? What do you think the 2 will do there? What did it do for sine and cosine? It changed the period, right? And that's the other thing that we want to see. The period of tan is not 2 pi. It is pi, because you can see here, it only takes from pi on 2 to 1.5 pi for it to be 1 cycle, and then it just keeps repeating itself. So a little bit of a star. Period of tan is just pi. So what do you think this 2 would now do? Squishes it. And so now we would say the period of tan, instead of 2 pi on b, it is pi on b. So therefore this period would be pi on d. And it just squashes it. And you can, in a moment, graph that yourself. Have a look either on Desmos or on your graphics calculator. Yeah? So have a look. Your asymptotes aren't going to show up on your graphics calculator, and I don't believe they show up on Desmos either. So play around, and I'll give you a moment where I can try and solve any issues you've had from previous questions. And you're playing now with these little ones. And remember, you do have your graphics calculator to assist you. We okay? Go to it, my beautiful beings. Okay, sorry. Thanks, guys. If we're stuck on A, what I would expect that you have done is things that we were doing before. So draw your original. Really handy if you have different color pens or pencils. So we're getting used to drawing our tan graph. There's our ridgy-dig. So nice. It's satisfying. Okay, we then look at this one here. And what do we know that that minus pi on 2 does? It moves everything to the right by pi on 2. Now, you might have been, and what you should have been doing is go, we haven't done one with asymptotes before. I wonder if it moves the asymptotes, yay or nay. So instead of sitting there guessing, going, you could have done a couple of things. One, you could have looked in the back of the book and seen what the sketch was. Ideally, what I would like you to do is look at your graphics calculator, type that in and see. And so what you would have noticed is that, yes, the whole graph moves over by pi on 2, including the asymptotes. So we have now got our vertical asymptotes going like so, which means our graph now looks like this. And you could have confirmed, doesn't it look awesome? You could confirm that with your calculator. So basically, this has now moved over by pi on 2. Okay? What do you expect is going to happen with this one? It's going to move to the left by pi on 3. Now, do you have to be absolutely precise?
No.
You don't have to, but for those of you out there, and I know you're out there because I've seen your books, notice for this question, because it was pi on 2, I counted 1, 2, 3, 4 little squares. When I'm doing number 2, that doesn't sound good, did it? When I'm doing the second one, what I will do is I will count, oops, not 6, I'm not going to fit it in. I'm going to count 1, 2, 3. 1, 2, 3. 1, 2, 3. Oh, did that work? Or maybe that will not work. 6, 6. Oops, you are right. 6. Oh. So 2, 4. So that's going to be my pi. 2, 4, 6. That's going to be my 2 pi. So now each one of these, this will be pi on 3. This will be, oops, not pi on 3, pi on 6. This will be pi on 3. So if you're going back into the old days of 30, 60, 90, and it just makes my moving of my asymptotes a lot easier, if that makes sense. Does that make sense? But again, if you go, I don't want to be precise, don't be precise. Do it nicely like this, and you could just say, oh, that wasn't pi on 2, that was pi on 3, right? As long as you label it. We happy? Good stuff. So everybody, we are trucking along. So with BCD, we've looked at the transformation of the sine, the cosine, and the tan graph, and you can see some similarities, and hopefully you're going, yeah, it's not too bad, I'm getting through. If you haven't had a chance to finish 1, 2, 3, 4, please do so before Friday. What we're going on to is our second to last little bit of this topic. Second to last. And technically, we have already done part of this, believe it or not. So, graphical. We are not even going to write anything down here. Have a look. We've got cos theta equals 0.4. It's between 0 and 10, and you want the solutions. So if we're looking at it on our graph here, we draw in the line. Can you see that little bit there, that would be the 0.4, because we're going up. 0.5 would be the darker line, just underneath is 0.4. Yes? Heather, are we watching? And all we're doing is we're saying, where does this horizontal line meet the cosine graph? And we read off that answer. We read it off, and you can see we've got 1, 2, 3 solutions. Because when we popped, if we just had cos x equals 0.4 back in year 9, we would have gone, inverse cos 0.4, we'd get our one solution, which would be this one. But now we know we can have multiple solutions. Yeah? I doubt you're going to be asked to do that with a graph, but if we were, let's go to the calculators. So sorry, we've popped those in, we've gone bloom. We are trying to do this question here. What do I need to do? I need to change my scale. Sorry, Felipe, was that too quick? So how do I change my scale? Shift, view window, and instead of going from 0 to 6, I'm going to go to 10. Now, I give myself a little buffer, so I'm going to go 10.5. There we have it. And we can go G-solve. What do I press? Intersection, right above F5 again. G-solve, intersection. We get our first answer. We get our second answer. We get our third answer. Okay, I'll do that again. So we've typed in cos4 and point 4. We go to Shift View Window. I was happy with my -1 and 1.6 as my y max and min because it was just cos x. If it was 2 cos x, what would happen? Max and min would be 2 and -2, so I'd have to change that. And why did I go between 0 and 10.4? Because I read the question. Oops. And it said, oh dear, it said 0 to 10. If it said 0 to 15, well then I would change it to 0 to 15. Press enter. They draw. I go G-solve and then intersect. Bang. Use my arrow keys. Alrighty. Let's go into normal calculator mode. And oh, look at that. I've got it up on the board already. Who can I'll just pause. How do we get to solve n? Yes, go. F3. Before I get to F3. Really? Option. So we're going to go options first. Then calc. And then we go solve n. F5. Okay. We go cos x. Where's your equals? It's above your decimal. And 0.4. Now, if I close my brackets and press enter, it would just give me random answers. I need to tell the calculator what values to go between. So I'm going to go, anyone remember? Comma, coming x, comma, 0, comma, 10. And then we press enter. It gives you the red scary screen, but we go, yeah, sure. Press exit, and those should be the same numbers that we have before. What we wanted to do today was get to solving, cease, get to actually solving equations. Right, by algebra. So I'm going to be asking you to watch a little bit of a video tonight, but what I'm also wanting you to do is not tonight, tomorrow night, is can we actually do question 7E1 where you are typing this into your calculator, okay, and using what we just did. That won't take very long. Consolidating. So, does it matter which one you use? For this one, they're saying use the graph. So, go into the graphing mode, and you can check it with G-solve. All right?